Hayashi here with Algebra 2.3, solving inequalities using multiplication and division. So solving an inequality, like I mentioned before, is like solving an equation. You still want to use inverse operations on the variable in order to isolate or solve for the variable. But there's one major difference between solving an inequality and solving an equation. I call it the golden rule of inequalities. Here's what you're going to have to remember for any type of inequality that you're going to solve, whether it's what we're covering right now, simple inequalities, multi-step inequalities later, okay, inequalities with the variable on each side, compound inequalities, whatever. The golden rule of inequalities is if you multiply or divide each side of the inequality by a negative, then you have to reverse. You could also say flip. You could also say switch inequality. That's a golden rule of inequalities. So at any time, if you multiply or divide each side by a negative, I'm going to underline that because it's by a negative, that's important. Talk a little bit more about that later. Then the inequality would reverse. You can also say you flip the inequality. You also say you switch the inequality. But we'll take a look at a couple of examples like that. All right, so these first couple of examples, or basically for every example, what we want to do is solve and graph each inequality. So we start with an inequality here. 6x is less than or equal to 24. Similar to an equation, we want to undo what's being done to the variable. So x is being multiplied by 6. The inverse operation or opposite operation is to divide each side by 6. So we're definitely not dividing by a negative here, which means we don't reverse the inequality. We keep the inequality facing the exact same way. Left side, we're left with x. We started with less than or equal to. We keep it exactly the same. X is less than or equal to, and 6 goes into 24 4 times. So x is less than or equal to 4 is the solution to the inequality, and then we can graph that as well. Even before we solve the inequality, you should know that on the graph it's going to be a filled-in circle because of the equal to sign underneath the inequality. By going to the solution, x is less than or equal to 4. You want to filled-in circle that 4. Since the variable is on the left, inequality points to which way you're going to make your arrow. Or it should make sense that less than or equal to would be to the left. And you want to make an arrow there, okay, not just a solid line or something with no arrow because it keeps going forever to the left. All right, and then example 2. Negative 3b is greater than 15. So the inverse operation here is, since b is being multiplied by a negative 3, you divide by a negative 3. Whatever you do to one side of an inequality, you do to the other side as well. If you're dividing by negative 3, here's where we're dividing each side by a negative. So on the left side, you have b. The right side, 15 divided by negative 3 is negative 5. But here's what you're going to have to remember every single time. Since we're dividing by a negative here, the inequality started off as greater than, so then it reverses or switches to less than. It's just flipping the inequality around. B is less than negative 5, and then we can graph that. 0, I'm actually going to go by 5s, negative 5. B is less than negative 5, so we want an open circle or a non-filled-in circle at negative 5. The variable is on the left here. The inequality points to the left, which is which way we should make our arrow. So that's the graph of the solution, but we did have to apply or use the golden rule of inequalities here.